Welcome to Ms. K's math class. In today's lesson, we will look at equivalent fractions. Equal fractions means that the fractions can look different because they're using different numbers, but they're the same size. So we can say that they're equal. For example, I have an example here that says 1/3 is equal to 2/6. And this means that 1/3 is the same amount compared to 2/6. And to show you clearly, we're going to use the same size square blocks here. So I have one square that is divided into 3 equal parts. To represent 1/3, I'm going to shade in 1 out of the 3 and call this 1/3. The one on the right, it is divided into 6 parts right here. And out of the 6 parts, I'm going to shade in 2 of them and call this 2/6. When we're comparing the green shaded areas, we know that the one on the left is the same as the one on the right. And this means that 1/3 is equal to 2/6. So we can call this equivalent fractions or equal fractions. Now, the definition of equal fractions says that when we multiply or divide the numerator and the denominator of a fraction by the same non-zero number, we obtain an equal or equivalent fraction. And this is what it means. We have a same non-zero number, first of all, and we're going to either multiply or divide both the numerator and the denominator of the fraction. And when we do this, we're going to have our equivalent fraction. So for example, here I have 1/3, and I know that this is equal to 2/6. So let's have a think about what we did. Did we multiply or did we divide to get to the equal fraction? So starting with the bottom 3, our denominator, what did we do to 3 to make it into a 6? We know that we times 2, so we multiplied. And we have to multiply the same non-zero number, which is the 2 in this case. So we're going to times the 2 to the numerator. And we know that by timesing 2 to the numerator and timesing 2 to the denominator, we were able to get our equal fraction. And does it work with dividing the numerator and the denominator by the same non-zero number? In fact, it does. So let me just show you. I'll get rid of the time signs that we used before. And now the arrow will just go the other way. So instead of starting with 1/3, this time we're going to start with the 6 and think about how the 6 became the 3. 6 became a 3 by not multiplying but by dividing by 2. 6 divided by 2 is 3. And does it work the other way as well? 2 divided by 2 is equal to 1. So that means that to the 2 out of 6, if we divide by the 2, the numerator and the denominator, we can get 1/3. And this tells us that these two fractions are equal or they are equivalent fraction. So this shows us that the definition of equal fractions is true. We multiply or divide the numerator and the denominator of a fraction by the same non-zero number. And when we do that, we obtain what is called equal fractions. The two fractions that look different with different numbers but equal in size. Let's use diagrams to see what equivalent fractions look like. Starting with the first one, I have two same size circles. The one on the left is divided into 2 parts. The one on the right is divided into 4 parts. And they are equal. So 1/2 means that out of the 2 parts, we only need to shade in one part of it. So I'm going to shade in one part of it to represent 1/2. What should I write for the fraction right here so that it equals to 1/2? First, start with how many parts the circle is divided into, and it is 4 parts, so I'm going to write 4. And I now need to decide how many pieces I'm going to shade in to make it become equal to 1 over 2, which is this much that I'm just outlining here. So we know that it is this portion that I'm outlining, and it is the 2 out of the 4 pieces, so I need to write 2. This shows us that 1 over 2 is equivalent to 2 over 4. Second example here, we have 4 out of 8. And that means that the circle is divided into 8 parts. And out of the 8 parts, we need to shade in 4. So I'm going to shade in 4 out of the 8. And to make this an equivalent fraction, using the right circle right here, it is divided into 2 parts. So the denominator is 2. And to make this equal, we know that we've got to shade in this much to make it equal to the one on the left. And so this is 1 out of the 2. So that shows us that 4 over 8 is equal to 1 over 2. Moving on to our third one, our circle is now divided into 3 parts. And out of the 3 parts, we're interested in 1. So we're going to shade in 1 out of 3 to show 1 over 3. And to make this an equal fraction, where the circle is divided into 6 parts, I'm going to write my denominator as a 6. And out of that, this is the portion I need to shade in to make it equal. And that is 2 out of the 6. And so we know that 1 over 3 is equivalent to 2 over 6. And the fourth one over here, we have a circle that is divided into 6 parts. And out of the 6 parts, we are interested in 2. So it's this much here, representing 2 over 6. And with that one, the next circle is divided into 3 parts. So the denominator is a 3. And to make this equal, this is the portion we need to shade in. And we're shading in 1 out of the 3. So that shows us that 2 over 6 is equal to 1 over 3. Let's continue with equivalent fractions by figuring out the missing numerator. So here the question says we have 3 over 4, and that equals to a fraction with a denominator of a 12. But we don't know what the numerator is, so that is our job to figure out what the missing numerator is. And the way to do that is to find out what we did to the denominator, whether we multiplied or whether we divided something. And if we can figure what we did to the denominator, then we do the same method for the numerator, and that way we can find out the equivalent fraction. So for example, with the first question here, starting with the 4, we need to think, what did we do to the 4 to make it become 12? What number did we multiply? Because we're going from the small to big number, starting with the 4, which is smaller than 12. So what did we times it by? 4 times what gives us 12? And the answer is 3. So we know that we now have to times 3 to the numerator. 3 times 3 equals 2, 9. And that means that 3 over 4 is equal to 9 over 12, and that these two fractions are equivalent. With our second question here, we have 2 over 7, and that equals to something over 21. So once again, looking at the denominators, we see that 7 has become 21. Because we're going from small to big, we know that we have to multiply. So think about 7 times what makes 21. So thinking of your times tables, you know that 7 times 3 will give you 21. Once we know this, we also have to times 3 to the numerator to find out what the missing numerator is. Now, the 2 times 3 gives us 6. And that means that 2 over 7 is equal to 6 over 21, and that these two fractions are equivalent. Third question here, we have 5 over 6 equaling to something over 30. So starting with the 6, it's become 30. So we're going from small to big. So we're going to times something to the 6 to make it become 30. So thinking of your 6 times tables, you know that 6 times 5 will give you 30. Knowing this, we have to times 5 to the numerator to get our missing numerator. So 5 times 5 is equal to 25. And that means that 5 over 6 equals to 25 over 30, and that these two fractions are equivalent. Question number 4, I have 1 over 8, and that equals to something over 56. So thinking about your times tables, 8 times something will give you 56. And the answer is 7. 8 times 7 gives us 56, and that means that we have to times 7 to the numerator. 1 times 7 equals to 7, and this means that 1 over 8 equals to 7 over 56, and that these two fractions are equivalent. Here we have 12 over 36, and that equals to something over 6. So we need to find the missing numerator, knowing that these two fractions are equivalent as shown with the equal sign. So looking at the denominator, it's 36 becoming the 6. So this time, we're going from the big number to a small number. So instead of timesing, we know that we'll have to divide 36 by something to get to 6. So 36 divided by something equals to 6. And what is that something? And the answer is 6. 36 divided by 6 equals to 6. So it means that we now have to divide by 6 the numerator as well. So 12 divided by 6 is equal to 2. This means that the 12 over 36 equals to 2 over 6, and that these two fractions are equivalent. Looking at the second one here, we have 25 over 15, and that equals to something over 3. So 15 became a 3 by dividing by something. So 15 divided by something equals to 3. And the answer is 5, because 15 divided by 5 equals to 3. So we now need to divide the numerator by 5 as well. And 25 divided by 5 equals to 5. What this means is that now the 25 over 15 equals to 5 over 3, and that these two fractions are equivalent. For the third one, we have 21 over 35 equaling to something over 5. So looking at the denominator, 35 divided by something will give us 5. And what is that something? 35 divided by 7 will give us 5. And that means that we now need to divide the numerator also by 7. So 21 divided by 7 equals to 3. And that means that the 21 over 35 equals to 3 over 5, and that these two fractions are equivalent. For the fourth one, we have a fraction of 8 over 20, and that equals to something over 5. So once again, looking at the denominator going from 20 to 5, we know that we have to divide. 20 divided by something will give us 5. And what is that? The answer is 4, because 20 divided by 4 equals to 5. And that means that we need to divide the numerator also by 4. And 8 divided by 4 equals to 2. And this means that 8 over 20 is equal to 2 over 5, and that these two fractions are equivalent. With this question here, they would like us to express 3 over 4 with a denominator of 20. First step is to rewrite this. So 3 over 4 and they would like us to find the equivalent fraction where the denominator is equal to 20. So write 20 for the denominator and figure out what the numerator is by following the steps that we just learned. So looking at the denominators, think about how the 4 became 20. 4 is smaller than 20, so it means we have to times something to the 4 to make it become 20. And so what would that number be? 4 times 5 will give us 20. And that means that we need to times 5 to the numerator as well to achieve the missing numerator here. And so 3 times 5 equals to 15. And that means that the 3 over 4 is equal to 15 over 20. So going back to the question, expressing 3 over 4 with a denominator of 20, the answer is 15 over 20. For question B, they would like us to express 2 over 6 with a denominator of 18. So step 1 is to write 2 over 6 equaling to a fraction with a denominator of 18. And we're finding the missing numerator. So looking at the denominator, thinking about how the 6 became the 18, we know that we had to times something. So 6 times what gives us 18? And the answer is 3. 6 times 3 is equal to 18, and that means that we need to times the 3 to the numerator, and 2 times 3 equals to 6. And so the answer here, where they want us to express the 2 over 6 with a denominator of 18, now the fraction is equal to 6 over 18. Express 15 over 20 with a denominator 4. So start by writing 15 over 20, and they want us to express this with a denominator of 4. And so we're missing the numerator. So looking at the denominators this time, the 20 became a 4, so it became smaller. If it did, it means that we divided it by something. 20 divided by what equals to 4? The answer is 5, and it means that for the numerator, we also have to divide by 5. So 15 divided by 5 equals to 3. And so going back to the question where it wanted us to express 15 over 20 with a denominator of 4, the answer is 3 over 4. Here's our last question for today. We have 24 over 33, and they would like us to express this with a denominator of 11. So start by writing the fraction that we have, 24 over 33, and the new fraction will now have a denominator of 11, and it's missing the numerator. So looking at the denominator, how did 33 become 11? So it's becoming big to small. So we know that we'll have to divide. 33 divided by what gives you 11? And the answer is 3. So that means that we also have to divide the numerator by 3. What is 24 divided by 3? The answer is 8. And this means that 24 over 33 equals to 8 over 11, and they're equivalent fractions. And going back to the question where it tells us to express the 24 over 33 with a denominator of 11, the answer is 8 over 11. I hope you found today's lesson on equivalent fractions helpful. Like and subscribe for more videos. Thank you for watching, and I will see you next time.